Okay, here's day 3, and I think I said in day 2 that probability has to be in between 0 and 1. Here is your lovely little chart that tells you that it's got a oh, I didn't turn my pen on. Sorry. There we go. Here's your little chart that tells you it has to be in between 0 and 1. So right here, right? And that's where, like, we always have, that's why when we were talking about rolling a dice or 6-sided die or whatever, it was like 1 out of 6 and it was 0.16 repeating. So probability is usually always in between 0 and 1. Now, we often very much write it as like 16% because it makes more sense when we're speaking to say, oh, there's a 16% chance that I'll roll a 1, as opposed to the probability of rolling a 1 is 0.16. Like, we don't speak like that. So that's usually why we convert it over to a percentage. This little thing right here, it's just the sliding scale of the, if it's 0, we call it impossible. If it's got a probability of 1, we call it certain. And then, you've got a 25% chance it's unlikely, 50-50 is our even chance, and then likely is 75%. Anything that has less than 0.05 or 0.05 or less is considered unusual and highly unlikely to occur. And the only other thing we got to talk about is the complement of an event. It is basically, hey, if I have, and it's we denote it by E apostrophe or E prime, depending on, who's typing. But it's basically, all right, if there's a 1/6 chance that I'm going to roll a 2, then there is a 5/6 chance that I'm not going to roll a 2. So that's really what the complement means. All right, let's do that. We have the same frequency distribution from example 7. So we have the whole 975 people. Find the probability of randomly selecting a social networking site who is not 23 to 35 years old. Now, what you can do is you can go and add the 156, the 254, the 190. You can add those numbers up if you want to and put them out of 975. But the actual easier thing to do is, all right, you know that you have 975 people. If you subtract, oh, sorry, not the 254, I apologize. If you subtract the 312 that are in that age range and divide it by 975, that total number of people, that means it is 663 out of 975, which reduces to 17 over 25, which is a probability of 0.68. So there's a 68% chance that you select someone who is not 23 to 35. Find the probability, I'm going to shrink this a little bit so I can, there you go. Find the probability of randomly selecting a social networking site user who is not 18 to 22 years old. And again, you would go find your 18 to 22, that's 156. So you're going to take your total number of people, 975, and you are going to subtract your 156. And so when you do that, it is 21 out of 25, or, oopsies, 0.84. So there's an 84% chance that you are not going to select someone who is 18 to 22 years old. All right, what do we got next? I think it's a spinner. All right, the probability experiment consists of tossing a coin and spinning the spinner shown. So the spinner has 1, 2, 3, 4, 5, 6, 7, 8 numbers. And we got to find the probability of each event. Okay, so here's the thing, guys. Tossing a coin. A coin has heads or tails, right? So that's 2 outcomes. And the spinner has 8 total people, or 8 total numbers. I almost said people. So that is a possibility of 16 different outcomes. All right. Find the probability of each event. So tossing a tail and spinning an odd number. So we could toss a tail, and then we could have 1 is an odd number over there. We could toss a tail, and what's another odd number? Okay, 7 is an odd number. We could toss a tail, and we have an odd number of 3. Or we could toss a tail, and we have 5 as an odd number, right? So it was 1, 7, 3, 5. I don't know why this is out of order. I really don't. I didn't make this spinner. So anyway, we have those 4 scenarios. where we toss a tail and get an odd number. So there are 4 out of the 16 total. So it's 1/4 or 0.25, a probability of 0.25. All right, so then tossing a head or spinning a number greater than 3. Okay, so here's the deal. You have got, here's the first thing. Tossing a head, so you could have head 1, head 2, head 3, head 4, head 5, head 6, head 7, head 8, right? So you could spin any of the 8 numbers as long as you tossed the head side, or you could get a number greater than 3. So your numbers that are greater than 3 are 4, 5, 6, 7, and 8. And as long, like you've already included them over here, but these ones you could toss and get, it could land on tails. So you have 8 from this section, and you have 1, 2, 3, 4, 5 from that possible. So you actually have 13 out of 16, or a probability of 0.8125 for that one. It's a little weird because you have to like because of the whole or thing. And we'll actually get into the or. I think it's next section, I think. I don't know. So because it's either this outcome or these outcomes is where you can pull that from. All right, last one, tossing a tail and spinning a number less than 6. So you are, it's the and again, so we don't have to worry about or. So you're tossing a tail and spinning a number less than 6. So you could do tail 1, tail 2, tail 3, tail 4, tail 5, right? And so that's actually 5 out of my 16 total, and that is 0.3125 as my probability. Okay? I think this is our next one is our last example. Your college ID number consists of 8 digits. Okay. Each code can be 0 through 9 and can be repeated. What is the probability of getting your college ID number when randomly generating 8 digits? Okay, we already did one like this in a previous example. So you have 8 digits, right? So we have 8 blanks to fill. 3, 4, 5, 6, 7, 8. And so what ends up happening is 0 through 9 means it's 10 possible digits the first go round. And because I can repeat, it's always going to be 10, right? 0 through 9, if you count that up on your fingers, it's 10. Now, if we wanted just the possible number of outcomes, it would be 10 to the 8th power, but we want the probability of you getting your specific ID. Well, you are the only one person who's getting that specific ID, so the probability is 1 out of 10 to the 8th. Okay? And then your college ID consists of 9 digits. And the first 2 digits of the number will be the last 2 digits of the year you are scheduled to graduate. The other digits can be any numbers from 0 through 9. Okay, so again, we've got 9 digits. 1, 2, 3, 4, 5, 6, 7, 8, 9. We've got 9 blanks to fill. The first 2 blanks, well, you only have one option for each of those 2 blanks because it's the first 2 digits of the number will be the last 2 digits. It's the last 2 digits of the year you're scheduled to graduate. So guys, if you're scheduled to graduate in 2020, it would be a 2 and a 0, and you only have those options, just those numbers. And then of course from here on out, it's all 10s because, we can repeat numbers. And so really what we have is that probability is 1 over 10 to the 7th.